collaboration with Concept 2, we have worked on two projects which directly involve rowing. First was a one-shot attempt to make an oar that might be better in some way. Second is an ongoing attempt to make the Concept 2 ergometer feel more like rowing. Paul King, a senior in mechanical engineering, modified some C2 oars in the fall of 1991. Basically, the idea was to reduce the amount of energy wasted in the interaction of the oar with the water. Any force between the blade or shaft and the water, which has a component in the direction of relative motion between the blade and water, corresponds to wasted energy, wasted rower effort. Our idea was to get the oar shaft out of the water using a bent shaft. Since the buoyancy of the oar shaft helps with height positioning, we had to add a piece of balsa wood to the oar blade. We also wanted to make a bigger blade, a blade with less length along the shaft, a deeper blade, and a flatter blade. The one-shot construction was not really successful. Nothing was learned about performance by using the prototype. The project did force us to think about the mechanics of oars, however, and we'd like to think that our thoughts influenced the thinking behind the new C2 hatchet oars. We continue to think ourselves about the mechanics of oars, though no construction is in progress. Since the fall of 1991, several students have worked on modifying the C2 rowing ergometer to better simulate rowing. Jeremy Rawlinson was the first. Jaime Estupinian continued in the spring, and Tim Cardana and Manish Naik have continued in the fall of 1992. Here the basic idea is to make the ergometer have about the same accelerations as a boat, and in response to the same rower forces and motions. A standard C2 is stationary with constant, 0, speed, while a boat has a large fore and aft accelerations. One idea is to put an ergometer on wheels, the idea behind our minor product, erg wheels. But here the center of mass is stationary, not the case in real rowing, where the center of mass of the person-boat system has an oscillatory acceleration. As the oar thrusts, exceeds, or loses to boat drag. In our design, the acceleration of the machine is coupled to the force at the hands by a drivetrain. In the prototype, the drag force is simulated by a long shock cord connected near the flywheel. Construction and design details have dominated over conceptual design issues. The students are not yet practiced engineers. Nonetheless, the design shows promise and does give ergometer motions, measured from video footage, similar to those measured on boats.